Thank you so much, guys, for coming out. I know the weather's really bad out today, so I really appreciate everyone coming out today. So thank you for that. We have Vincent here, will be our trainer. He used to be actually the engineer for Green Manufacturer in China, and now he works with TOSOT. He's going to start us off. Today's going to be for central heat pumps and for ductless heat pumps. Okay, at the end of this session, we're going to provide everyone with a TOSOT certificate through email. So make sure at the end you see Jinan. She's going to help you with all that at the very end. Okay, so yeah, we're going to get started right now. This is Vincent.
Hello, good morning everyone, and this is Vincent speaking. And today our topic, I just come to here not to give you training, but I just come to share my understanding about the Unix and what we call is this condenser unit. And if you have any question, you can just feel free to interrupt me and ask your question. Okay. So our first topic is about this Unix. It's too small. It's the condenser unit, the introduction. Let me go adjust something. Okay, and my sharing divides into these 5 parts. First of all, what is Unix? Actually, from this diagram, you can find that here is our TOSOT outdoor unit. It is just a condenser unit. It can also connect with the air handler, that one, and besides, it can also connect with this I core, also over there. And for this air handler, we support vertical installation and horizontal installation, either it is left or right. And also, for this one, we also support the duct flow or the default upflow. And besides, we also support third-party thermostat, this one, which means you can choose the Ecobee or Honeywell if we just require is support the 24-volt communication. I'm sorry. And for this combination, you can use the furnace. Yes, we just need the air to blow out to achieve the cooling and heating. So to summarize, we just need to use our TOSOT outdoor unit. So you can together with any third party or TOSOT, a coil or the air handler. And here is the base model. What we call is the unit 18. This 18, that means the series. Let's go to this one. And also the capacity is from 2 ton to 5 ton. There are 2 cases. 2 and 3 ton, they're the same. 4 and 5 ton is the same. And the power supply is 200 single phase. And this is the unit 16. Just compare with the previous one. The performance is not that high because the maximum is only this 16, which is this one. And there are these 4 cases of the outdoor unit. And as for this air handler, there are 3 cases. For this one, it is a non-repair. And this combination is the outdoor unit together with the A-core for both cooling and heating. And this is the outdoor ambient temperature for cooling at the left side and for the heating at the right side. So let's focus on the cooling first. We support from minus 15 until this 54 for unit 18. For 16, it's only 48. But I think in Toronto, this condition is quite enough. And focus on this part for the heating. Unit 18 can work until minus 30, but unit 16 only minus 15. And later I will explain you the reason why it can work until minus 30. And for unit 18, we also claim for the 2 ton, we can maintain 100% capacity until minus 20. And the next is compare with the traditional top discharge model. Our unit is all the side discharge. So the benefit of it is the footprint. You can find this comparison. The footprint is we can improve a lot. So for this one, you can install the outdoor unit not only on the rooftop or on the ground. You can also put it at the balcony or hanging in the wall. And for the next part is the product features. And first is the compressor, and this is the comparison between the on-off compressor and the inverter compressor. I think you're already familiar with this part. And to summarize, we can make the compressor to adjust the frequency and also make the end user to the room temperature not fluctuate that much. And here is the compressor comparison. So we have these 3 kind of the compressor. For the unit 16, it is just the regular train rotary. This train rotary, that means inside this compressor, inside there are 2 compression chambers, also called rates. And that's the reason why we call it 3. And for the unit 18, it is the also 2 train rotary, but it has this EVI. EVI is short for the enhanced vapor injection. And also similar to the 5-ton model, that one. So, anyone who can tell me what is this EVI?
Enhanced vapor injection.
Yeah, what is the detail meaning? What is the detail of that? Or what is the purpose of this one?
Enhance the power.
Okay, and the reason is for the regular or the high standard compressor is just one in and one out, right? However, when the outdoor arm bin is low, but at that time we still need the the high pressure to be very high. But if the outdoor arm bin is low, at that time we need the pressure difference of this compressor will be very high. In other words, the refrigerant flow rate would be extremely low. And what is the consequence if we make the refrigerant flow rate to be very low? You don't have enough heating capacity.
Right.
In other words, the air blow out from the indoor side will be very low. And the customer will just complain, the device or the equipment is not heating. And that's the reason if the outdoor arm bin is low, let's say if it is less than the freezing point, then we will turn on this injection, which is to inject some more refrigerant into it. You can also find that if inject here, then you will have another bypass to here. The purpose of it is just to increase the refrigerant flow rate. And that is also the reason why the unit 18 can work until -30. And then we will go to the heat exchanger fit design. Actually, in the factory design system, you can find that we have these 3 structures. One is the flat, that means the surface is completely flat. And also the other is the corrugated, that means if the surface just like this, we make it to be up and down. And next is the surface we cut most of the slit on it. And the purpose of why we make it to be this 2 is just to increase the airflow. We need to make it to be more turbulent. And the benefit is for the heat transfer. As you know that if we make it to be more turbulent, the heat transfer efficiency would be higher. So from this comparison, from the heat transfer, this one is definitely higher, right? Because we can make the airflow by to be more turbulent. However, one of these, there is a disadvantage. Do you know what is it? Yeah, correct. And especially here, when the outdoor arm bin is lower than the freezing point, it will easily to make most of the frost at the outdoor condenser, right? And then we need to make the defrost, which is to make the ice to become water. However, during the defrost, the water can easily stick in this slit, which makes it difficult to flow out, and then it can make easily to become ice again in the next heating cycle. So from this comparison, we just choose this corrugated fin instead of this slit fin. It's the outdoor condenser fin structure. And also for the outdoor unit, there are heating belt for the unit 18. One is at the compressor heating belt, and the other is at the chassis. The chassis, the purpose of it is just to melt down or to guarantee the ice, the water, it will not accumulate the ice during the defrost. And of course, if the outdoor arm bin is extremely low, for example, less than -10, in this area, although we can guarantee there's no ice or the water can flow easily from the drain from these cheeses. However, the drain hose, if there's no heat strip, it can also make it to be frozen, which means the water cannot flow because of the cheese is not heat enough, not hot enough, but just due to the drain hose. And next we go to the metering device. And for the units, we just apply this electronic expansion valve at the outdoor unit for heat tank metering. As for the cooling metering, we apply this thermomatic expansion valve. Can anyone tell me where does it locate? Yes, it locates at the indoor, either the A coil or the air handler. And here is just a comparison for your reference. What is the benefit and what is the difference between these three metering devices? And next is for the outdoor unit function setting. And this is for the unit 18 and this is the unit 16. So we have LED here. And with this one, we display the operating status and the parameter, and also we show you error codes. And besides, with these three buttons, for unit 18, you can also choose the manually or the forced defrost, or even to recover the refrigerant, or even you can make a test run. Just you will ignore the input of the 24 volt. You just operate at your command. This is for the test run. And next for the air handler. For this one, this is the method to guarantee you can achieve a high RPM. Also, by adjusting this switch, you can also increase or decrease the ESP. You can also choose this emergency kit installed at this area, which is at the discharge side of the air handler, and which is this one. For the third part is for easy for a short installation introduction. Just like what I had said, for the air handler, we support horizontal left or right. Just pay attention to the drainage. It's okay. And the default of the air handler is upflow, but you can also use this adapter to make it to be downflow. And we also provide you a video. You can just scan this QR code to access the YouTube. And here is for the wirings. And I just put here, this is the outdoor unit, air handler, and the thermostat. So from this wiring, you can just follow this one to do the wiring is fine. And also this RC, and it is actually the 24 volt communication. Just one attention, it is this D. Anyone who can tell me what is this D for?
Defrost.
And the purpose of this one is during the defrost, we intend to stop the air handler fan, because during the defrost it's actually the cooling cycle, right? And then if we don't stop the fan, it will just blow out the cool. And although it is a good idea, however, those of the customer or the installer do not fully understand this meaning. It will just make the customer to complain, why my fan not operate? So, sorry. No need to take a video later. I will show you where to access to our sharing for this presentation. Okay. And this D is, sorry. if we get 24 volts from here, you just stop the fan. And the customer, if they complain, and it's not that easy to make them understand, my fan is stopped. So our recommendation is, if you are not familiar with our system, you don't need to wire the D. Just leave it open. It's okay. And for the highlight restriction, from the outdoor unit to the indoor, either it is the A coil or the air handler. First question, we already understand the outdoor unit, there's some temperature inside. How about the indoor side?
Yes, still have that.
Yeah.
Yes.
But what I can tell you is either the air handler or the A coil, there's some gas inside. So on the job side, you just need to vacuum the copper tube. Is okay. And we just have the restriction, or we have the limit about the total piping length and also the height difference. Make sure you are within this range. And if it's longer than the pre-charge range is 30 feet. Within 30 feet, no need to charge anything. Longer than that, to charge additional amount is fine.
What happens if it's short?
Short is okay. The short is 3 feet.
3 feet?
Yeah,
Yeah. You don't have to take it out every time?
yeah.
No?
No need.
No need.
Which means within, if your highlight length is within 30 feet, no need to do anything.
Right.
Just vacuum the copper tube is okay.
Okay.
And I also show you an example how to do this installation and charge. Which means from here you can find it. If the total piping length is 40 feet, so you need to do the max, which is 40 subtract 31 and times this amount. You can get this how much you need to charge. And for the deep fill, it's just the outer unit with the A coil and together with this furnace. And all control is for the thermostat, which means if the thermostat find out it required for the heat pump, then it will turn on the heat pump. But if the outer arm beam is lower than your setting, then it will turn on this furnace instead of the heat pump. I think it's very common here, right? And
Does the unit have a balance point or it's too cold outside, it runs the furnace instead of the heat pump?
according to your setting, which means all is the thermostat.
Yeah.
And for the furnace, for the A coil, we also support all the directions. Either it's horizontal or vertical. Just like what I said, just pay attention to the drain pan. Always guarantee the drain pan at the lower side. And for this upflow or for the vertical installation, we only recommend to install this transition. The problem is due to the heat. Yeah, if we heat up too much, we just afraid that inside the drain pan is still not sustainable.
But on your sample, you didn't install it.
Yeah, you can also find it. There's no transition. If we recommend, just recommend. And for this wiring, this is for the deep fill, and it's very similar to the periods. And always don't forget to set this when to jump, select the other side. And for the final part is the small summary, which is the outer unit. We can also connect with the air handler or the A coil. And for the A coil, you can choose the blower or the furnace. So this focus this one, and for this one, is support horizontal or the vertical. And for the heat tank is from -30 to 24. Cooling is from -15 to 54. And if it's for a retrofit project, we also support the third-party air handler, but we only require it should include this TXV. And also similar to the others. And the next is the comparison between the traditional and our Unix. So I just compare this 45 kBTU. So you can find it for the max height difference is almost the same. And for the operating range, and for this we can make it up to -30 degrees Celsius. The reason is we apply the EVR compressor, and just like this one. And also the oil return operation, just due to the host is the inverter, so we require the oil return operation. And the oil return is just for the only for the inverter. Do you know why? For the on-off, there's no oil return, but for the inverter compressor, there is always an oil return operation. Okay, and the reason is for the inverter, we can lower the compressor frequency, right? And for a long time operation, if the compressor is at a low frequency, we're afraid that too much oil will trap in the exhaust side, which means the compressor will be short of oil, and then it will make it to be burned out easily. So to prevent this, we require the inverter compressor to make it to a high frequency during the oil return operation, then flush the oil trapped in the indoor side to flow back to the outdoor. And that is the oil return. And the most important is, for this comparison, most important is the footprint, and is 1/3 improved, and also the noise. And this slide, you can scan this QR code to access this sharing, which means including all our TOSOT. It is the TOSOT library. You can access not only the condensing unit, but also the mini split, single zone or multi-zone, and even the VRF sharing material. And at the left side is the YouTube channel. I also upload all our sharing video there. You can watch the video anytime you like. So for this part, is there any question? So if no, I will go to the next section. Next topic. It's the this is how to do the outdoor unit function setting. So as you know that for the Unit 18, this focus is one. It divides into these two cases. Smaller cases is 2 to 3 ton, and bigger case is 4 to 5 ton. And how actually they just share the same this PCB. We identify the bigger or smaller case by this jumper cap. Also, you can find in the jumper cap that there's a number there. So this one number there, and the bigger case and smaller case, the jumper cake number is different. And once we identify it is a smaller one or the bigger one, we use this switch to identify it is which capacity. So you can find it always the first bit. 2 and 3 ton. If the first bit is different, the capacity is different. And also if 4 and 5 ton, the first bit, if it is different, also means different capacity. For the unit 16, we use this jumper cake to identify the capacity. So, yeah. As for the second tip of this unit 18, that is for the how to do the defrost. We have the standard one and also the strong, also called enhanced defrost. And what is the difference between these two? It is for the enhanced defrost one, we will make the defrost to be more completely, and which is to adjust the parameter like continuously heating period, we make it to be shorter, which means for the standard one, let's say it will every 45 minutes to judge whether it meets satisfy the conditions to do the defrost or not. But for this strong or the enhanced defrost, we will every 40 minutes to judge and judge which conditions it is the defrost sensor value, which is this one. The sensor value, if it is the original one, we make it to be -3, and for the enhanced one, we make it to be 0, which means we make it to easier to enter the defrost. And also during the defrost, we make it to be last long enough. And for the number 3 and number 4 tip, it is how to achieve your set point. And we have these 4 conditions. And of course, the first is the default, and the second is strong, also called fast cooling and fast heating. And the number 3 focus on the energy saving, slow down the heat up or cool down speed. And the number 4 is self-action. It's not that easy for understand, so I just make a diagram for your better understanding. So in this diagram, we have here is the time, and this is the room temperature. So for the room temperature, you will have the set point, right? And then the room temperature start point from here. So for the first one, you will have this, which is how long we will take it to reach the first set point. We call it to be T1. After that, it will just fluctuate a little bit. So if we choose to be this T2, this number 2, then it will make this time to be shorter. First achieve the set point. And number 3, focus on the energy saving. It is longer. And for the number 4 is this. So from this diagram, we have this. Number 4 is only for the unit 16 only. So in this diagram, we have this time comparison. We have this relation, and after that, how we can keep the room temperature to be stable. Also, we have this sequence. Actually, on the job side, you can just ask your customer which side they just focus. If they focus on the fast cooling and fast heating, you can choose number 2. If it just focus on the energy saving, you can choose number 3. And if they don't say anything, you can make it to keep it to be default. It's okay.
Can everyone see the slide at the bottom? In the back?
So you have stands, you move the stand on the way.
Actually, I have shared all this material on the Google Drive.
Perfect.
The-
We'll provide the slides for everyone afterwards. Yeah. But,
Yes, and for this slide, you can just access the QR code when I displayed in the last slide.
Yeah.
To access to the Google Drive. I put all this sharing material over there. And for this function setting, also you can use these buttons to enter for different functions, just like what I said in the previous introduction. And here you can just follow these instructions to enter different functions. We provide you the force defrost and the refrigerant recover, and also for the text run, which is the system will just follow your instruction to do either cooling or heating. You don't need to wire the 24-volt communication. Yes, and just this QR code. You can scan this one to access all the sharing material. And on the next side is a YouTube, TOSOT YouTube channel.
Yes.
So for this outdoor unit function setting, is there any questions? So if no, I will go to the next topic. And for the next topic is the air handler, how to do the setting. And from here you can find it. This is the Unit 18, the PCB, and also similar for the first step is identify either it is a bigger one or the smaller one. And how to identify the bigger one or smaller one is by the jumper cap. First step for the capacity, and as for the number 2 to number 4, it is the ESP level, which is the fan speed level. And just follow this one to do the adjusting is fine. And also at this PCB, there's some LED here to indicate whether the system, whether the air handler is malfunction or not, and which is the old pattern, which is to count the fresh. If the fresh pattern is just like this one, also means it is something wrong. And also, as you know that for our units, there's no communication between the indoor side and outdoor side. We only display the error code at the outdoor side, but for the indoor side, only displayed by this LED flash. And at the indoor side, and this is the and for this one is you need to adjust the ESP for the indoor ducting, and if you apply this wrong duct, that means it will increase the pressure difference to be very high. And if the customer just complain you that air handler is too noisy, but you can just show that you need to guarantee enough CFM. If the CFM is not enough, you will make it to be like this. You will have in cooling mode, there are lots of the ice accumulated here. It is freezing. And this is the CFM, just for your reference, for different levels of the air handler. And next, I'd like to ask you that for this indoor unit installation, how will you adjust the ESP, or will you adjust the ESP? Will you check the refrigerant pressure for the installation? In heating mode, what is the pressure should be? The refrigerant pressure, yeah. Roughly is fine, no need to do. Really? Is the refrigerant pressure?
That's the high pressure.
What is your target? You will have a target, right? And what is the value? You don't know? I don't think you can. It should be around 350 to 400 psi, and then you make sure the pressure you can get to that. Then that means your system is okay. And the pressure, what I mean here is the compressor should turn on at least 15 minutes, which means you make it until stable. Then you can check the pressure. That is okay. If at the first beginning, let's say 5 minutes to check the pressure, it's not that good. So for this part, is there any question? So we'll go to the next section. How about we just take a break for 5 minutes? Yeah, and the next topic we go to the ductless, mini split ductless system. And before that, we have a 5 minutes break. Okay.
Here.
这谁的？
没谁啊，这没人坐，
可以坐吗？啊，
没人坐，坐呗。
不能坐这儿。
可以坐是啊，谁说不能坐？
我什么时候来的？
我今天第一个来，
哇塞，我来他妈的2个多小时开了。
我走的是西安。
不是，走哪里都不关键，关键是他妈堵得一塌糊涂啊！
How are you? You are here.
Yes.
How about that product? You got it?
Like I have to like I sent my so I'm waiting. What's going to happen next?
Anytime.
Huh?
Anytime you can call us for help.
Yeah, like if that's okay, like I will go that another project. I'm trying to get all of this.
Yeah. No problem. So if you need any problems, you can go to the car. My guy always there, okay?
Hey, you can send me prices. Do you have the price list?
No, we don't have the price list. If you want anything, you can always get the lowest price.
Like for the gas temperatures, I need to rent
Okay, I will check that and give it to you. No worries. Okay, thank you so much.
哦，我以为是领导做的。
哪他妈的，你就是领导。
我来到这儿8点40。
我是7点40到的。我早上一大早起来，他妈6点钟起来，然后那个时候就已经开始了，我就走。
快点，他们还把这个放这干嘛？这个
有洗的人，口子都是来的。手机在吗？没有网上。
刚才把车里头上说话问题不是。
我刚才出来不知道把那个 AirPod 弄掉了。刚才风大风没大，我
那这会儿离的。
今天早上没起来。
要不刚刚我进来我才看到怎么只有一个，
没注意到，
肯定找不到了，这么小的
很难找，
也不知道在哪掉的。刚才上来雪太大了，我停到那下面，我停到那下面，
我停到那下面去了。
是啊，下面
好没有，还记得那这个有个问题太矮了，
我错了，在这里，
我觉得这里
违规的，这个东西整个东西上，它对那个对的货，拿违规的跟这个没有关系，拿违规的是我们要在安保网站上去。
今年怎么样？
哎呀，
五天两个，这个比别的是没有，
那是我们自己公司的那个成本，跟这个没关系，我们不可能每个品牌没有可能性而已。
没有啊，现在是补贴500块钱一顿嘛。
你说和这个人民20年，
我们没23年
，23年都没有便宜。
你说的是23年，
我说
对，地也行，
我跟24年是一样，
这个地也
去年没他做，
我没有，
去年但去年根本就没做。
去年没做，
我3个空都有，
去年就卖，
对，我3个空都有。你是考试啊？我8年前都可以，9年前都可以，我到现在没去。
对，
我2016年把那个东西都发过来，我钱都交了。现在找不到哪去，
装2个人，
我们卖给多少
250。
谁这么补？
我是2016年这个这个college 我退，就发个邮件了，我说你可以，我钱都交，你不过
12年5怎么说？
然后就跟你发个那个
1250，
这个税都交了。
对啊，你就跟以前装个约个空调一样，那时候装外设机都有600块钱的，没有什么区别，没太大区别。
我告诉你。我们都没登记，
这个你说
去年装这个还是装的，我这装10台，今年10来台，1推1的也有，1推2、1推3的，加上1推1的话，可能有15台到20台。去年在他们家买飞，相对来说算是便宜的。但现在美的也进来了，美的的话，我知道西里这边去过吗？他们那个展厅那个当时买到的时候，我们帮他们接那些管子，
你完了，真的是
就帮他接了，换了个东西。
锅底是
对，锅底。我们主要是帮他做，因为他当时原来是仓库嘛，前面改造办公室，然后就改成公馆，然后还有后面 UDP 的有几个坏的，帮他去，然后他那天有一天他们那个美的人过来，然后他们把机器挂上去，我们的人就帮他把它挂起来。
不是说到米沙港那个，说的是米沙那个是吧？米沙那个我真没去。
就在那个正好
啊，
就隔一台机。
那个算什么呀？他们这边那个 office 算什么？
这边叫 Relax。
哦，他分开了。 但是老板不是说我比较多。
可能就管因为他自己隔开了，他自己专门做另外事情的那个因为原来不是没在我给你贴牌嘛，但现在就是每年他可以自己可以进来。他跟我说法是原来银行跟 Carry 还帮签了合约，15年前签的，好像是15年前，15年不能牌子不能进来的。
我经常是管 FedEx 还是管？
他这边没有他
哦，他没在 FedEx。
因为他知道美电进来，所以他可能是有生产美电。
拿货应该拿的，价格还可以。
因为我现在没有进口，我就每天都没有进口，他别的价格货应该也差不多，
差不多的，肯定跟那个 FedEx 差不多。
哇，价格给我，价格给我那个和 FedEx 价格基本上是一样的，基本上一样。因为别人就说中国人来说的话，你如果说知道是不是美的生产的一样东西的，价格差太多的话，会。
那美的听着好听点。很多老外都知道美的嘛 ，Media 我们老外知道，你说 FedEx 他可能不知道。
这他们前2年，然后他自己做那个。
就跟这个一样，说沃桑他不一定知道，但是你说 Green 他就一定知道，一样的道理。去年那年我们也知道过，他就一定要 Green， 就是巴基斯坦国际的，可能他们国家也用的。他没遇到那
这个牌子呢，后来做的牌子，所以很辛苦。
但这个牌子好像在美国可以，
之前他们也就是说，因为打市场，所以他自己谈不好。所以他可能就他们做时间长久了，像 Predex 因为做的太短，所以你不知道。到时候有可能他在美国做的时间长一点。
那你今年如果要装，怎么装呢？
价钱
不便宜这个呢，选择太多了。多上 FedEx， Green 可能太贵了。是啊，会贵点。Green 那边培训你去过没有？我去过一次。他那边没那么多人，因为他把机器放在那里，只是跟你说，这个，他那个小。对，但他全是没有中国人，知道有，反正我去那些，但是他给的价格太高了，从来没去他那里。
我是之前去法国这边，因为客人一定要有吧。
是，我们也是，
因为他一定要。
是啊，我就说巴基斯坦一定要。
因为他一定要有才有办法，其他要不然我之前拿的都是他家的，还有就是还有那个 Predex 的也，还有那个还有 T 的，
开不懂，
没拿过。和那个美的，和 Predex 机器是一样的。
那我们便宜点点。
是因为后来因为他们进的是动玩，你知道吗？进的动玩，他价钱还实际上是这样的。
我猜呀，这个最便宜还是美的。我猜你最后就拿美的。因为他们的量更大。
就前2天发了一个单子，他们也正常的机器人一样，2个人大概900块。
正常的就是一般的空调，
也是美的牌。
长得也一样是吧？这个还可以。拖衣吗？拖衣他卖吗？还是要另外买？他们可能不点拖衣。
它那个正常机器无所谓的，连换都行，就正常机器无所谓。这种正常的买机。
就是我给他个买，其中关2吨是吧
3吨的是每吨大概贵100块钱的样子，2吨的话就是1000多一点，然后3吨可能1000，将近1200，大概就是这样。
现在我觉得还可以，还可以。去年我们装最便宜是约克吧，就约克，
就是一个大的拿对吧？
一个12还有那个什么叫
Please return to your seat.
就在这附近，
概念多少？
差不多，他们差不多。
Hi guys, we're going to start
990
again.
那个很少，
6万232啊，还要另外买表是吗？我都去听过他的课，他要另外买个表，
下面买。
对啊，还要买个234。
也有些是要什么是那个也有，他们也但是也要个新的表。Lennox 还有别的牌子，因为是不是力？
怎么样？2月1号转，现在是Lennox那还得去那些大公司吗？
没有，就是
太少了。
它没有额价钱，除非是这样的，比如说我一天要买30台，那他给我价钱可能跟我他们的买的一样，那我也是不要。
我是去年的质量，我知道你装的多不多。出了好的问题。
装的我去年其实空调啊，暖气
没有，比赛不多，可能比我多嘛，就一双手。表面的刮呀，厉害的，我遇到好多次。
就说那个真的是 ML 的。
以前没遇到过，就去年遇到好多次。
Hello, gentlemen. Gentlemen, we will start. Please return to your seat. So okay, go ahead. So in this chapter, I'm going to show you how to identify whether there is an error and how to handle it. First of all, what is an error? It is because our system always keep watch or monitor all the important parameters. For example, the compressor temperature and the pressure, and also guarantee that is in our design range. If it is exceeds our design range, we will report you to bring your attention to this unit. So let's say just like this one, we have the regular. Sorry. We will have the regular range and also the protective control zone. So let's say the compressor temperature, the discharge temperature, if it is exceeds this or enter this protected zone, we will make some solution like lower the compressor frequency or increase the refrigerant flow rate to cool down the compressor, which means make it to go down. And also, if it's too low, also we have another solution to make it to become higher. And if it is this protected zone, we need to stop the system and report you the system is something wrong to bring your attention. Because if it continue to operate, it will damage or make the compressor to be malfunction. So how to check the error code from this unit is on the outer unit. There is an LED here. We display the error code from here. So on side, because the customer cannot open the outer unit panel, you need to open the panel to check what is the error code. And after that, you get the error code. There are basically two solutions. First is the service manual. We indicate the error code here and what is the determinant. From this determinant, you can get an idea how to fix this one. And the other is you can go to this website, support.grid.com. Anyone can access it. And here I will just display you a video how to check this determinant of the error code. So from here, you just input this website web access here. This is the error code page, and you can select. Let's say it's C4. What's the determinant? We'll show you here. And the units it equals this GUD. So you select this GUD. We'll display you what is the determinant of this C4 and how to judge it. What is the solutions for this error code? Just for your reference. And then this part already introduced. The next, I'm going to introduce the most common error code. Okay.
Oh.
So far for present, it is this P6. P6, that means the communication error between the control main board and the compressor joint board. And the judgment is there is 30 seconds in a row, the control main board, you see the signal from the compressor joint board. So on site, you need to check the wiring, which is this two, which from the control main board is AP3 to the AP2, that is connecting AP4 board. So you need to check these two wires, and also this one, the 3 wire. Besides, also you need to check the socket, whether it is fully inserted, the socket. And the last is that there is something wrong with the PCB. You need to replace it. And there is the most common error code. And and the next is for the forward valve malfunction. For this one is very, it's not that common, but if it happens, it's just due to the there's no error code because the system will not judge this one, but the customer will complain it's no heating and no cooling. The reason is this one, because inside this forward valve there is a slider. You just use this slider to change the direction, and this I will display you a small animation how this forward valve operates. You can find that there is a pilot valve here. That is actually a small size of the forward valve. It also connects with the high pressure and the low pressure. And we just use the system, the pressures inside to change over. You can find it currently it is heating mode, And if we would like to change it to be the cooling mode, how the system, how this boiler will operate. You can see the direction already changed. So on side, if you have five, it is not cooling and heating. First, you can identify is to check the temperature between this E and C. If the temperature if it is normal, it should be the temperature should be huge. If I is almost the same, that means it is malfunction. Malfunction, that means the inside side is like this one. It just start at the middle, and then the refrigerant from the compressor cannot flow into the E or C. That means the E or C tube is the temperature is almost the same. And just like this one, you can just feel the these two pipes. And later I will show you videos how we fix this one for temporary, which is this. First, you can find that the compressor noise is huge. And then our service person also checked which is to the two pipes to feel the temperature is almost the same. This we already know it is malfunction, so we just use the screwdriver to knock the boiler valve body. You can see already fixed. This is only for temporary.
Would that be damage to the compressor?
Yeah. And next, I will show you a diagram for better understanding. And here is also another wiring. So let's assume that if the customer just complain, why my equipment is not heating, what will you check? It's always in cooling, even I set it to be the heating from the thermostat. What will you check? Which wire? Yes, wire OB. So in our device, we should make the feed to be energized. If it is no power, that means it is cooling mode. And on the job side, you can also jump the wire from R to this B, which is this one. You can see it jump from R to B. Then you can identify whether it can do heating or not. It's the most easy way. So is there any question for the compressor unit? If no, it will be finished. We will talk about the finish split.
Can I ask you a question? Yeah. When it goes from heating to cooling on the defrost, does it go while it's running, or does it shut off the unit?
Could come again?
When you're going from in a defrost mode, when it goes into defrost, does it shut the unit completely and then start up defrost, and then it's finished and it comes out?
Yeah. And
Because it's not carriers or different writers, they will actually do it.
And the point is we need to make the reversing valve to be change direction, right? Right. In our control program, we make the compressor stop and then change over. Yeah. Okay, since there's no question, we will go to the ductless.
去年的好是开空调的时候就开不了了，又把电关了，又送上，然后又工作。
也碰到过两次，
我碰到是6个7个月，
那个打算就让他重新 reset 一下。
我就不知道今年到了夏天还会不会影响。
So I think you already fully understand the single zone mini split is very easy. You just connect the copper tube and the wire. It's okay. So here I just mentioned a little bit about the multi zone. And for the outdoor unit, here is the space you need to guarantee. And also at the bottom there, you also provide you this adapter to connect with the drain hose. And if you would like to hang it on the wall, please attention that. No, first of all, I need to ask you a question. For this 4 wall, which one is available to hang the outdoor unit on the wall? Which one? Only concrete? Yes, correct. The safe one is the concrete, or the brick one for the wooden and the drywall. Although it can, but just due to the noise will be very strict.
Heat pump is not safe to install on the roof.
Yeah, 5 ton is of course easy. Yeah. Okay. And next is the most important for the multi-zone installation, which is we need to guarantee the wires and the piping, the sequence, it should be the same. And we also indicate this A, B, C, D. And here the A, B, C, D, you need to guarantee they are the same. And also on the job side, if you install this A, B, C, D indoor units, always you make it just like this. And also, I need to ask you a question that when you pull out all the copper tubes and the wires to the outdoor unit, how you can identify them from the same indoor unit? Is there any method or know-how how to identify them from the same indoor unit? Because you need to guarantee the sequence, right? And when you pull out all the pipes and the wires to the outdoor unit to do the wiring or the connected tube, how can you identify them from the same indoor unit? Okay.
Is there any light in my PC?
Any ideas?
Any light? Sorry, I didn't get the question. I didn't get the question. What's the question?
How you can identify the wires and the copper tube that from the same indoor unit?
For the continuity.
Container base?
Look for the continuity. If the continuity is there, then it belongs to the same unit.
Sorry, I didn't know that.
You find 2 wires inside.
Yeah.
Unit A, then you check outside. If it is like check for the continuity for the home unit. If there is a B, that means it's a
Yeah.
做记号。
Yeah. We also use the multimeter, which is
Yeah, the old
you said.
should have some light. 是不是上来？
Just the multimeter, the community. Just check the earthing with any tube. If there's a bead, that means they're from the same indoor unit. And just attention, this should not connect to the outdoor unit. Okay, just the wires, the earthing wire with any tube is okay. If there is a bead sound, that means they're from the same. And if this one with this, there will be no bead sound.
这个线跟那个同款，这个。
And here is another example. If your customer just complain like this, watch this video.
When you see the major condensation problem with my heat pump in my master bedroom, I haven't even turned it on, and it was just like this when it was turned off, and the condensation accumulated. Please ask Lucky to come and check what's going on. Please get it fixed if you can, and please contact me. Thank you.
So you can find that the customer just complained that this indoor unit is not turned on, but there are lots of basic water in the service. The reason is just due to the wrong sequence. And later I will also show you the diagram how the refrigerant flow will cause this problem. Which one can? Yes, no fan. But the coil is very cold.
This is why the best situation for this unit to run it separately to make sure it's sequence is right. Because if you run all of them together, you will not see it.
And later I will also show you the reason why, how to check. And here is the piping restriction or the limit for the mounted zones. So we have the restriction for the total piping length and from the outer unit to the furthest indoor unit. Just like this one, to the furthest indoor unit. And here is the maximum height difference. And also height difference between different indoor units. And also we have the pre-charge amount. If it exceeds this length, you need to charge additional refrigerant. So, and this is the refrigerant diagram of how the system diagram, cooling cycle of how the multi-zone refrigerant flow. And on the right side, I put the outdoor unit. Left side, I just connect with 4 indoor units. And also, I put different color for the refrigerant status. Either it is gas or the liquid, or either it is the high pressure and low pressure. So on the outdoor unit, we have the compressor, void valve, outdoor heat exchanger, and this is for filtering device, the ESV. And also this is the liquid separator. Yes?
Can we move that? The stand, I can't see it.
Okay. Thank you.
Thank you.
So make it simple, how the refrigerant flow in cooling mode from the compressor. Let's say this 2 indoor units requires cooling. So the refrigerant from the compressor will first go to the outdoor unit and release heat, and then it will become the liquid. From this liquid, this time there's only A and C require cooling. So this A and C ESV will just do the metering. And then offer this cold refrigerant to the indoor side to make it to absorb heat. And then it will become the gas and flow back to the outdoor unit, just like this. And here is a question. How about for this B and D, the ESP, how it be operate? I give you some options: fully open, fully closed. Which one?
Fully closed.
Fully open. Who says that? Attention, this is the indoor unit B and indoor unit C, indoor unit D. There's no cooling required, so we will keep it fully closed. Then there's no refrigerant flow by this B and D. So if we make it to be the wrong sequence, how about this time? And also assume this indoor unit C, indoor unit A require the cooling. But this time, the system will make this indoor unit A, so this ESP A to be open to do the metering. Although there is no fan operate, and that is the reason the indoor unit B will become cold. And just like the video, you'll remember what the customer just complained, why my indoor unit don't operate? But there are lots of the condensing water at the panels. That is the reason why. And also, you can find it for the indoor unit A, even if you call for cooling, but there's no refrigerant supply, that means it cannot do cooling. It just blow out the fan only. So here is the comparison with the piping and the indoor air discharge. If the correct wiring, or if the sequence is correct, and if it is incorrect. So for the first one, we can just find that for the pipe, which is focused on this one. You can check from the indoor side from here. It is chill, and also the air blow out is chill, and also the same for the indoor unit B. So if it is incorrect, the temperature is focused this one. It is regular, and how about for the indoor unit B? The piping, it should be chill, and also air. Also, it should be chill, right? Yes.
So about whole units, is it possible to have some units provide cooling, some units provide heating?
No.
That function is called heat recovery at the same time for this. It's not possible. Even for the VIF mini, the reason is not enough space. For the cold discharge, we have the heat recovery series, and also we have the heat pump series. This simultaneously cooling and heating is only for heat recovery series.
They have two compressors?
No, we have the branch box. Branch box to select the indoor unit or this pipe, this branch is for the cooling or heating. Yes. So for the cooling wiring, is there? Am I clear for this part? Okay, then we will go to the heating. And also, as you know that for the cooling, we can identify whether the sequence is correct or not, right? By checking the pipe, the intermediate pipe temperature. So how about for the heating? This time also for the heating and the wiring and the piping sequence is almost the same. So let's analyze how the refrigerant flow first. And this time, assume this indoor unit A and C is called for heating. And then the refrigerant will flow to the indoor side first. Then after this heat become liquid and flow back to the outer unit. And only at this A and C we will do the metering. So like this. And this is the heating cycle. And question is for the how about the unit B and D? Is no heating requirement. My question is how is metering device is ESVB and ESVD how we operate? Fully closed, fully open. Which one? Fully closed. Really?
Yes.
Are you sure of it?
Yes.
Okay, I'll give you the answer. Actually, this control algorithm is complete. Is almost the same, no matter the manufacturer. Which means even Daikin, Mitsubishi, and also LG is the same. Which means for the multi-zone system. And I'm afraid that for this in unit B and D, the metering device we just open a little bit, and I will show you the reason why. And because there's no valve to stop here, we still offer the hot gas to the indoor unit B and D, right? And then if we make it to be fully closed, what's the consequence? Do you know? No. And if it make it fully closed, because this gas is still hot, that means it still release the heat to the air, right? No matter of what, it's still hot to release heat, and then it becomes the liquid. That means more and more refrigerant will become liquid and accumulated at this in unit B and D. And if too much refrigerant accumulated there, that means the circulation refrigerant for the A and C will be not enough. In other words, the A and C will be short of refrigerant. And there's a reason why we need to just open a little bit to make the refrigerant still flow through this indoor unit B and D, even they are not called for intake. And there's also the reason you can check from the indoor side, this B and D, the fuel temperature is almost the same as the operating one, which means this B and D, the temperature is the same as the intake on, cooling for heating and cooling not cooling for heating. This temperature is almost the same. That is also the reason it is very difficult to identify in heating mode.
So zone B and D also will feel like heat.
Yeah, the Q, you can also feel hot.
I mean the space.
Yeah. This is almost impossible to identify from heating. What I mean is the sequence, whether it's correct or not.
So people can feel the heat in the space that like zone B and D.
Yes, in that case. Yeah, this is the result. If we make it to be fully closed, what is the consequence? Just like what I said, if we accumulate all the refrigerant to be here, and then make the A and C not insufficient refrigerant, which means it will make it to be poor heating for this A and C. So let's analyze if it's incorrect wiring. The sequence is incorrect. Also, zone A call for heating. At this time, we just offer the hot gas to the this one, and also you can find it here. It's hot. But we still, even if it's not for heating, we still call for we still open a little bit for the refrigerant to flow through. You can see here is summarized. Both A and B, the tubes are, the pipes are warm, which means cannot identify, even if it's the fan off. And here is another summarized configuration. If it is correct, wiring, either the pipes or the air supply both will be warm. And in incorrect, also wrong. And how about the unit B? Also wrong. Also, that indicates in heat table you cannot identify. So, is there any question for this ductless installation? If no, I think today's my sharing is finished.
Thank you. So does anyone have any questions? We can do like a quick Q&A. If anyone has any questions. Yeah.
Is there a telephone number in case we have to call service tech?
Sorry about that. What's that?
Is there a 1-800 number for calling service tech?
Yeah, so actually at HVAC X,
Yeah.
we have someone pick up the support.
Yeah.
Call anytime,
Yeah.
7 days a week.
Right.
And find you at the phone number right after this. We'll try to put it up there afterwards.
Okay.
So we have someone 7 days a week.
What's the warranty on it? Like,
It's
for
10-year parts, 10-year compressor warranty.
what's the labor warranty on
The
it?
labor warranty is just a regular contractor, 1 year.
1 year.
You can purchase an extended warranty if you like.
Yeah.
But I have to double check. It's around $300 for a 10-year labor warranty.
10 years.
10-year labor warranty. There's also a choice for a 5-year labor warranty.
Yeah.
I have to double check.
Yeah.
And they pay $25 an hour.
How much do you pay per hour to do it?
Sorry, I believe it's 105.
105.
105 each.
I think
Yeah.
that technician should buy this.
It's through a company, I think it's through Prime.
Through Prime?
Yeah, so we would register for you.
Yeah.
And then, yeah, so if you have any labor warranties to claim, $105 an hour.
105. Okay.
Any other questions? Well, Vincent's here. Any technical questions you guys want to ask him? He's like the perfect person to ask. We have this sheet out here. We're doing like a quick sale items. Any of the Armaflex, like 1/4, 3/8, 3/4, it's only $100 per box. So it's like 30%, 40% less than our usual price. We have some really good pricing on refrigeration copper disconnect box, sheet metal 2436, 2448, S-plate. So there's a bunch of items. If you want, you guys can fill it out, provide it for us, and we can call you guys tomorrow. Or if we have a bunch of stock on the truck, you guys can take it right now. Yeah, so if there's anything you guys need on this sheet, just let one of us know. I think it's me or Ravel. Ravel is somewhere over here. Where's Ravel at? Yeah, he's in the back right now. So if you guys want to take any of this product, you can take it now. Yeah, or you can fill it out and give us the sheet today, and then we can have that ready for you for tomorrow. Perfect, thank you. So right now, we're gonna create a little bit of a lineup, I guess, by the door over there. And then there's a QR code we need to get from you guys, and then we'll send you the certificate. Alright. So let us know if you guys need anything. We're open 7 days a week. Alright, so let us know if there's anything you guys need. Thank you so much, guys. Thank you. Sorry, it's gonna be over here. So we can create a lineup over here, and then yeah, we're gonna sign you guys up.
我先搞，我先搞。
然后他上台的那个每天上次因为我们第一次碰到客户的原因，然后他正好那个最后的没上班。
他的那个什么，因为都是代码说的。
我帮你按时间，你把这个牌子，反正给时间。
Anyone cards if you're told to just leave the line?
长得要30岁，我是不是想自己的客人，那你这个机器你不能保证它永远的值，因为我们就是给1年的合同，但是我项目在不上面事情。在一面我说11点。
Yo क्वेश्चन में नंबर आना है कि नहीं क्वेश्चन That's it. Oh, yeah. Stands. It's all looking. Yeah, I think one trade is here. One trade is here. You're good. Watch your good. Right. Henry, you're good. Brian, you're good.
那个才是新的东西。
没有，它主要是神态。就像我说的，它应该像合金一样，换一个机器在里面。
可以调的更多一点。
Hello, you good? You gotta get. Samir, you good? I think all the sergeant kids will be convinced with you guys. So don't worry. Once you get scanned in here, the sergeant kids will be convinced with you. John, you good? Karu, you good? Yeah, who's ready? All right, Leon, you good? Come on, you guys. Okay, Ali, you're good? Yeah, right. It's gonna be emailed to you. I'll try to get it emailed to you. There should be a in the same email. There should be a training, TOSOT training. Wow, you guys. There should be a QR code.
Which one you are looking for?
Hey guys, you guys got it. You guys got this one? You guys
Which email?
the email that was sent from ESPACX? Yeah, you guys should get it there. Go to view event. Now there should be a QR code as well. You registered?
What I did is this.
Get there. Register. So put in your name and just register. All right, Fong, you're good. Mohammed, you good? You got it? Come on, you good? Somebody, you're good? got that?
So as soon as you sign up, you get
Yeah, you too, man. Good one.
If you have any problems, just come to John right
Hi, how are you? This is Samir Lama from RSC there. Yes, for a few days I'm not getting my emails. Last 2-3 days. Please do tell me, something.
You're good. You're good. Yeah, what's right now? You got it. Perfect.
Anyone here with the QR code? So we have this. So we have this. You're good.
I'm through.
So if you need to sign up, anyone with the QR code? You have to go to Janan. She's going to send you. Yeah, you just
Or you know what? Then you're good. Good. You're good. Yeah, so, yeah, price that in the board. Got him. Yeah. Mike, you good? You good? I'm Jerry, you good? Take care, man. Thank you.
Anyone have a QR code?
Yeah. All right, I'm just good. guys got good right there. I know. So you got yeah, don't forget you guys have nothing to do with the sale. Just take whatever you want. Write the us, write your company's name and everything else.
I just saw it, was it now?
Hey, thank you. Appreciate it.
We're all this load of duty. Yeah, working. Why you're here? You good? You still working on it? Oh, no.
So we're just gonna, we're going to talk about the QR code. There's one of the three. Scan it there. Once you get that,
They scan this?
Yeah. Before they already defined. Now they won't have to define.
Yeah.
This way you have to be certified.
Yes,
Good job.
Oh, I think
Really need to
they want to check.
answer.
Yeah, so I think it's like submitted.